Right, hello and welcome back to another video. This week we're going to be having a look at to do this effect. This is a Screenspace stabilized UV projection. So no matter where I move my camera or move my objects, the textures being projected in Screenspace, taking into account object size and scale, creating this effect here. This is an answer to a question from a different video about putting a gradient always on sort of the side of an object in Screenspace, and I think this is going to be useful in solving that for them. And big thanks to Jan Kaluza, hopefully I'm saying that right, who is a tech artist at Epic Games now. He originally did this technique on Twitter, and I have his permission to recreate it here, so big thanks to him for that. Okay, so before we get into how we're going to do this in Screenspace, we're actually going to do it first in world space, and then we're just going to basically take the same idea and apply it in Screenspace. It's a bit more complicated in Screenspace, and so by doing it in world space first, hopefully we can see the idea about what the logic is that we're going to be recreating in Screenspace. Okay, so if we just connect up a world position here, this will give me a world position gradient. And I'm just going to divide by a large number in order to see it. World position values are very big, so they get very bright very quickly. And if I divide by, let's call this world space scale so it doesn't overwrite the other one, something like that, 512. So world position gives us a gradient of values per pixel for our objects. And if I take this cube, let's make a copy. If I put this in the origin, you can see we've got a gradient in each axis. So as I move further along in the y-axis, the gradient here starts at black and goes up more and more green, more and more blue going up, and more red going this way. So we've got a infinite continuous gradient of values. But it's based around the world 0, this center point here. Now that's kind of half of what we want, but we don't want it here around the origin, and we want it around where our object is. And so I'm going to move my object. What we're going to do is we're going to take the object position. Where is the object? Now this is actually the center point of the object's bounds. There is actor position, which would work as well. In this case for my cube, they're the same. The bounding box center and the actor position pivot center are the same. And I'm just going to use object bounds. I think that works better, but object position. So if I subtract one from the other, what do I get? Well, now I've effectively moved the origin of where my gradient is. I'm still getting the gradient from the world position, but now the center point, the actor position, or in this case object center, object bound center, moves that, and that's effectively what we're going to be doing in Screenspace. Now a couple of things. If I scale this up and down, the gradient doesn't scale with it, so we need to be able to take that sort of component, and we can do that by taking the object bounds. Now this is a 3 vector debug float 3 that gives us a output based on the size of the object. So this cube here is a 128 cube. If I change it to the plane, we can see we don't have anything in the X dimension because it's paper thin or 0 thin. 128, and then a sphere. Sphere's apparently it's a 160, and that's what this max is doing. So if I put it on a plane here, you see we're getting a 0 value there. Well, I'm going to divide by this value, and I don't ever want to divide by 0, so I'm dividing. So I'm just maxing this out at 1. If we look at that, this now top value here is going to be 1. So that's what this is doing here, is giving us the ability to scale our object. If I go back to my material and preview this, let's take this ad out for a second. I'm now dividing by far too much. There we go. So now by taking into account the object's bounds, and so if I scale my object, the gradient actually scales with it. So I no longer need that large divisor that I had before. and we can see we're getting a gradient that is mapped to the object. And I've done videos about this before, so if you want to know about object local bounding box gradients, there is a UVW bounding box based UVW function that comes with the engine. So all these things, yeah, are there. The last thing we're doing, currently our gradient starts at the center here. Well, if I take the object's bounds and then I add that to my gradient, what I can do is I can move this 0, 0 point to be in the corner, and that's what I'm doing here. So by taking the bounds, add it together, what we should see is that gradient now starts here. So we've now got our 0 point here in the corner, and we've got a 2D gradient there, 2D gradient there, 2D gradient there, etc. And we can obviously use that to do UVs or whatever we want, mask things out. But this is all in world space based on this object. And if I rotate it around, you can see we still get the same result, but it doesn't work so well when it's not kind of aligned with the axes. And we'll see the same thing with the view space stuff as well. But this idea, taking a gradient that goes an infinite amount from 0 to lots, taking a fixed position where our object is, and then doing some scaling in addition to get things to be the right sort of scale and position for where our start 0, 0 point is. That's what we're going to be doing the same, but with Screenspace instead. So let's have a look at how that works then. So I might just, yeah, we'll just go through these bit by bit. So screen position. So screen position is a bit like our world position. What that does is it outputs our Screenspace UVs. So if I move my screen to be fully covering my material, we get 0, 0 here, top left, 1, 1, bottom right. And that is useful. That is giving us our infinite gradient, a bit like world position. So this is our sort of base gradient, and we now need to control it. Now there is an issue with this. Maybe we'll come back to the issue. So now we're going to kind of work out where our object is. So this is our infinite gradient, our world space. Where's our object space? Well, we can take our object position, input data, and we can do what's called a transform to clip space. Now what's clip space? So clip space is part of the sort of rendering pipeline. Before your object is converted or your values are converted to screen space, they live in clip space. Now I'm not 100% sure, because I'm not a render programmer, but effectively clip space and screen space are sort of same parts of the same pipeline, and there's lots of information you can find about clip space if you want to delve deeper into that. But what this is doing, well, it's taking the object position and it's giving us a value now, converting where it is in screen space. If I take a debug float 2, and just output this value, we can see here our object is at these UV coordinates. So up here it's getting to be -1, -1, or 1, -1. Down here I can see that's going to be -1 both in the corner. That's +1, -1. And up here is 1, 1. So it's giving us a 0 to 1 output, and if you mouse over this, clip space value in -1 to 1, for our object's position in clip space. So where is it on the screen? Now, unfortunately, the axes for this are different from the axes from our screen position. So we need to correct that, and that's what this multiply is doing. So by multiplying by 1 - 1, we're just inverting the green axis, and what we should get now is positive values down here, and then 0, 0 effectively, or it's not 0, 0, it's -1, -1, but our lowest point is up top left and our highest point is down bottom right, and that matches up with our screen position. So now we can use those two things together. Cool. Now the values here are 1 to -1. If we multiply by a half, and we'll come back to these two in a minute. Let's just keep that out of the way. We'll take our viewport UVs and we'll subtract half of our clip space values. And what we should get is a UV square, or a UV gradient, that is attached to where our object is. So as this object moves around in Screenspace, you can see the same gradient on it everywhere. And if I take that and just plug that into a texture sample, might be a bit easier to see. Oops. Texture sample. And I've got this grid that I'm going to use. You can see our grid is attached, or is stabilized, isn't moving relative to where our object moves around. Now there is an issue. Hopefully you can see this. There's some stretching. Now we haven't taken into account the aspect ratio of our viewport. Now this is something we didn't have to do really. Well, we did with our object scale, but now we need to take into account of our sort of UV viewport scale. And if I stretch this out more, you can see we're actually getting stretching in our texture based on the aspect ratio of the screen. So what can we do about that? Well, actually, if we come down here, we can get the view size. And what this does, if I just do debug flip 2 again, love these things. This gives us a 2D value of our screen size, our viewport resolution. So in this case, it's a 495 across, 420 up. And if I bring that out, you can see that dynamically changing. So it's the size of the screen of the viewport we're currently looking at. Now that's what we want. We want to be able to take this into account, but we don't want to use it as these whole numbers. What we want it as is a ratio. And so if we take out our two components, divide one by the other, and then append one to it, what we can get is a aspect ratio. So in this case, our vertical distance or vertical size is 0.7 times our horizontal width. And as we change this, we can do that. So just remapping those values into a more usable way. So in this case, it's the vertical distance divided by the horizontal distance, and then we're just taking that and doing 1 and append it. So this is always 1 because it's a ratio of 1 to that size ratio. Oops. Cool. So we've got our view ratio, and now we just need to apply that to our screen position and object position. Now there's a little trick or a little extra step here. Our screen position's currently up here at 0, 0. Well, we're going to bring that into the center first and then apply our ratio. So we can do that with a constant bias scale. Here we're just subtracting a half and multiplying by 2. So there's a little bit of kind of remapping values from 0 to 1 and then -1 to 1 that you need to do to get this to work. But that's easily done with a constant bias scale. So now this is in the center, we can multiply by our aspect ratio, and that will have stretched these gradients so that they now remain square regardless of how the viewport ratio is. And then we just invert the same thing here. So add 1 times a half versus -1/2 times 2, and that will put 0, 0 back up into the top corner. And we do the same thing here, bring that in, and just multiply these values. So these values are always in already in -1 to 1, so they don't need to be offset because the center point 0 is already at the center. And what we should now see, if I go back to my texture sample, is the texture is square, and no matter what I do to the viewport, it remains square, which is cool. Works really well. One more little feature, or one more little thing to add. Currently, if I zoom my camera away, my texture is just mapped in Screenspace. It's not relative to the size of the object on the screen, and that's probably what we want to do. We want to make this appear or scale based on how far we are away from the object, and we can do that again taking the object's position. In this case, we're going to transform that position to view space, and the B value, or the blue value of view space, gives us a depth or a distance. Now it's very high values. Yeah, I see a gradient kind of coming in. If I take this and let's debug scalar, this is giving us a value of how far away is the object from the camera, basically. So we're taking the view space and the other components of view space. If I do red, this is going to be how far away from the center it is. So again, 0 being the center of the screen, minus this many pixels to the left or to the right. And so you can get information about your object and where it is in Screenspace using these transforms or convert to clip space. And there we are. And the blue channel is the distance or the depth. Now, if I multiplied by this value, and just say, keep this one out of the way for now. So I'll take my my UVs, and I'm using an inbuilt node here, scale UVs by center. And if I, let's just do this and this. There we are. So if I take my my distance to my object in view space, now if I've just multiplied by that, instead of using this 1 minus here, what we're going to get is we are going to get an effect, but it's basically the invert of what we want. Let's debug this again. Picking things apart when I should maybe just be making things from scratch. But so we've got a value here based that's very small when we're close and very big when we're far away. And if we're scaling our UVs by this value, well, we're going to get very big values. So what we want to do is take the invert of this. So divide 1 divided by it. And what we should then get, if I just debug this, a bigger value when we're close, a smaller value when we're further away. And if that then goes into our scale UVs, it scales based on the size of the object. So if I bring this down, there's my my grid. We have 8 grid squares top to bottom, and then as I get closer to it, we're reading the distance here, object position, transform to view space, mask out blue, and then we're multiplying by the invert of it, and that means that it's getting bigger tiling as we get closer to it, and vice versa. And the ratio of tilings are the same, so it looks like it's always got the same mapping. But this isn't mapped with texturing with UVs, it's all done in Screenspace. Now there's one more issue, and that is if I apply this to my object. I've got some planes over here somewhere. Oh, let's actually apply the material properly, not just have the preview. So that all looks good. UVs are scaling as we get bigger and smaller, or as they get closer and further away. But if I take my object here and scale it up, that's not too bad on this one, but should be giving me, it's not too bad, okay. Okay, well, I mean, that is working as a fixed value. So what the original material has in it is a multiplication of the object radius. So just taking into account the object size, but actually with it being in Screenspace, maybe that isn't necessary. That's all fine, because it does seem to be working. Okay, well, as I say, we'll see if we'll put it back in, and we'll see what the original, as it has the original material had it, and we'll see if it makes any difference. It does change this scaling factor. It may just be a simple thing of making it easier scaling factor wise. Aha. I see. So this is what it's doing, is it's taking the object scale into account. There we are. So do you want to have the object scale itself affecting the UVs? Or the screen space projection, I should say, because it's not UVs. Or do you want it to just be the same size squares everywhere, regardless of the size of the object? I guess it depends very much on your use case. But that's how we do it. We take the object radius and we multiply that in, which makes sense. The bigger the object, the bigger the radius. Now the bigger the UVs are going to work as well. So up to you if you want this or not. If you don't, now all of our UVs are going to be projected in Screenspace. Now the scaling obviously changes. They are projected there. The grid is there. It's just incredibly small. And so we want to scale by a big value to make that visible. There we are. So now, regardless of the size of the object, it's always being projected screen space. Or if we multiply by the object radius, it will be different depending on the object. And there we are. So 2 options. Okay, so quick recap of what we've done so far. So we've taken our screen position UVs, we've taken an aspect ratio of the X and Y values, so the width and height of our screen, and then offset to the center and multiplied, and then offset back to the top left corner where our 0 point starts. We've taken our object position in clip space, fixed the axes so that they match, and then again multiplied by a half so that the 2 sets of values are in the same sort of coordinate system, and subtract one from the other to stabilize it to the center. Then we can also scale that one thing by distance, so taking the object position into view space and taking the reciprocal, so 1 divided by that value as a scaling factor. So the closer we get, the bigger the UVs, or the bigger the tiling on the texture. And then we've got an optional section here. Do we want to multiply by the object radius? If so, we'll get different values based on the size of the object, but it's relative. So here we can see we've got nearly 6 squares. I could probably fix that. Windows are all the wrong size. There we go. So we could do that. So it's a 4x4 square here, and regardless of how big I make the object, it's still going to be a 4x4 square. Or we can not multiply by the object radius, and then our grid projection will be the same on every object. Just be aware that the scale factor is now very different. And now it's the same size squares on both objects, regardless of how big the object is. So again, depending on your use case, which is pretty cool. Okay, one more feature that is included in the original material. We can do bump offset. So taking those UVs that we have calculated here in screen projection, plugging into a texture map. Here I'm just using an engine normal. I'm using the blue channel of the normal, which looks a bit like a height map. Obviously your height map would work better. Here's for a sec. Depending on what you're doing, we've got a height map here, and we're going to use that as a bump offset. Now we're not just using the bump offset node, because we're using the projection UVs. What it's going to do is it's going to bump towards the screen center. So effectively we can kind of create a sort of parallaxing, almost fisheye-like, I guess, kind of projection, where the bump offset's not just from the texture outwards or inwards, but towards or away from the center point of the screen. So UVs into our texture, multiplying by a value, taking again our screen position UVs, subtract a half to move it into our center, and we can just multiply those two together. So now we've got our height map bumping this thing, and then add that back to our original UVs. And that's going to give us this bump offset effect. So if I disable this, enable that. Oops, no, come on, that'll work, fine. If I change that to true, our tiling here is a bit too big. Before I start this, so you can see the bump offset having an effect. It's maybe a bit strong. We can adjust that. What it's doing is it's bumping towards the center point. So here, this sort of center bulge, these values are being pushed towards the center. And if I move this around, you can see it's always pushing towards that center point, which is quite a useful effect, or potentially quite a useful effect. If we're looking straight on, we're getting more of a undistorted view. Makes your eyes get a bit funny. Cool. Now we can change the reference height, where to bump from. Currently the values in the sort of bulge are moving and the values here in the flat areas are static. If we just subtract 1 from our height map first, we now get the sort of opposite effect where the values are changing the other way around. So you can adjust which bit's doing which, depending on how you want the, sort of the reference height of your bump offset to work. Cool. Yeah. Interesting effect. Not sure how useful it would be or how useful it is. Definitely ways of creating a gradient in Screenspace for an object. Depending on the view angle, obviously the Screenspace changes. And so having something that's always being kind of like, whoops. How are we? Okay. That's always in some kind of sort of everything that's always on the left of the screen. That is what that's doing, but it changes kind of the ratio of how much into the object the left is, if that makes sense. So if I stretch this out, you can see our sort of center point or start point of our gradient 0 depends very much on the center of the object. Now it might be possible to always map from one end, but then what you're going to get is values at the other. What you kind of want is to remap Screenspace so that this is 0 and this is 1, but I don't think that's possible based on the current view of the object. You'd have to get the screen bounds and change things, and it would give you lots of smearing and that kind of thing as you're moving around. So an interesting effect, might be useful for some UI elements or some kind of like appearing. You might want things to appear across the screen, something like that might be quite nice. Some kind of magical transition as the landscape changes from decayed to beautiful. You could do that in some kind of Screenspace thing. But bear in mind, as the camera's moving, the effect would also move. So anything where the player has control of the camera might cause problems with this, as they'd be able to sort of move back and forth and change how the transition works. But as I say, an interesting effect with a few interesting nodes and setup in here. Okay, yeah. Hopefully that is helpful. Hopefully there's some interesting stuff there. As always, big thanks to the original person asking the question. Thanks to Jan for solving the problem and letting me sort of tutorialize and share this. If you are interested in materials, I have done a materials course in Unreal 5. You can find the link on my Gumroad. So do check that out. Part 2 is going to be coming next year. We go much more in depth into more advanced VFX type, tech art type materials. So do look out for that. And as always, big thanks to everyone who supports me on Patreon. Yeah, do check out that as well. So hopefully that was interesting, and I'll see you all next time.